Hello everyone. So in this video we will discuss that how we can delete a node from a singly linked list at a given position. In our previous videos we saw that how we can insert a node in a singly linked list at a given position. So now we'll see that how we can delete a node from a given position in a singly linked list. So here you can see, let's say we want to implement a method to delete a node at a given position. So for example, let's say if we are given with this singly linked list and we need to write a method delete which will take in a position, and we are assuming the position to be valid, which means it should lie in the boundaries of the singly linked list and which should start from 1. So let's say in this singly linked list, if we want to delete a node at position 1, then that would be this node, which is the first node of a singly linked list. So we are assuming that it should start from 1. And let's say if we want to delete a position 3. So this is position 1, position 2, position 3. So this is the node which we want to delete. And we are assuming the position to be valid here. So let's say if our singly linked list has 4 nodes, and if we pass position as 6, then either we need to throw an exception or we can assign a position to a value which points to the last node of the singly linked list. So based on these two assumptions, let's see the algorithm. So before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So let's say if we are given with this singly linked list having 3 nodes. So there arise 3 cases where we can delete a node from the singly linked list. One would be if we provide the position as 1, then we are telling that we want to delete the first node of the singly linked list. And let's say if we provide position 2, then we are saying that we need to delete the second node which is between node 1 and node 3. And as we are assuming that we are starting from position 1 with first node, here node having data as 8 will be position 1, this would be position 2, and we want to delete this node. And after this deletion, node having value as 8 will not point to this node, it will point to node 1. And the third case would be, let's say if we want to delete the last node, so we'll pass the position as 3. This is position 1, position 2 and position 3. So this node will be deleted, and the second last node, which is this node, will point to null after this deletion. So let's see these 3 cases. So let's say if you want to delete the first node, so we simply provide a position as 1. So in the code we simply check whether position is equal to 1 or not. So if position is equal to 1, then if part will be executed. And in order to delete this node which is being referred by head, what we simply do is we simply assign value of head.next to head. So head.next is the second node. So we'll simply assign head.next value to head. So now head will point to the second node. So it looks like this. So as we are deleting the first node, head is pointing to that node. So we can't directly delete this node, because if we directly delete this node, then the rest of the nodes will also get removed. So first we do is we simply assign head.next value to head so that the rest of the singly linked list is being referred by head. Because after deleting this node, our singly linked list will become 10, 1 and null. So once this assignment is done, this node is being not referred by any other node, so this will be garbage collected. So it looks something like this, that now our singly linked list becomes head is pointing to node having value as 10, and node having value as 10 is pointing to a node having value as 1. Moving ahead. Now let's say if we are given with this singly linked list having 4 nodes, and let's say if we want to delete any node in between of the singly linked list. So let's say if we call delete method with value as 3, which means we want to delete the node at position 3, which is this node. Now friend, as it is a singly linked list, in order to delete this node, we need to somehow traverse to its previous node. So how we can traverse to this previous node is, let's see the algorithm. We check whether position is equal to 1 or not. So position is equal to 3. So this condition comes out to be false. In the else part, as we want to delete the node at position 3, we need to somehow reach to position 2. So what we do is we simply create a temporary list node by name previous. We'll assign a value head to it. So it will simply start from the first node. And our task is to make it reach to a node having value as position -1. So here, as we have already started with head, we will create a count variable having value as 1, because this count variable will help us reaching previous to a node just previous to a position from where we want to delete this node, which is this position. So we need to provide a while loop, and in this while loop we provide a condition as count should be less than position -1. So position value is 3, and if we do -1 it becomes 2. So 1 is less than 2. So the condition in while loop comes out to be true. And inside this while loop we simply traverse previous to its next position by assigning previous.next to previous. So previous next is pointing to this node. So after this assignment, previous will point to its next node via this reference. So it would look something like this. And as we have incremented previous to by 1 position, will increment count by 1. So count becomes 2. Now we'll again check whether value of count, which is 2, is less than position -1 or not. So 3 minus 1 is 2. So 2 is not less than 2. So this condition comes out to be false and while loop will terminate. And here you can see that as we want to delete the third position, we have reached to position 2 via this while loop. So after this while loop, now our task is to delete the node at position 3. Now as we want to delete this node, and after its deletion, this node next should point to this node, because we don't want to remove this node along with this node, we only want to remove this node. So our task is to break this link and create a link from this node to a node after the node which we want to delete. So at the first step what we do is, we can't directly remove this link here, because if we remove this link, then this complete singly linked list will be garbage collected. And in order to reach this node, we also need a pointer to this node as well, because if we have pointer to this node, then we can use its next value to reach this node, because we want to somehow assign previous next value, which is this value, to this node. So at the first step what we are doing is, we are creating a temporary list node having value as current, and we are assigning previous next value, which is this node. So it would look something like this, that current is pointing to previous next. And after this, it becomes very easy to delete this node. As we discussed, previous next should not point to this node, it should point to this node, the node next to our current. So what we do is, we simply assign value current.next to previous.next. So here you can see current next is pointing to this node and previous next is pointing to current. So we need to break this link, and we want this link to point to current's next, because if we break this link and we assign it to this node, then this node can be freed up easily. So when this assignment will be done, current next value, which is this node, will now get referred by previous next. So it would look something like this, that this link will go away and previous next will now point to current's next. So it would look something like this, that now previous next is pointing to current's next, because we want to free this node from the singly linked list. And after this assignment, when this method will get complete, we know that current was part of this method as a local variable. So now current will be simply garbage collected, because there won't be any reference to this node after this method gets over. So it would look something like this, that it would be deleted. And now if we rearrange it, it would look something like this, that now node 10 is pointing to node 1. So this was the case when we deleted a node which was between the singly linked list. So now let's say if we are given with this singly linked list and we want to delete the last node, which is at position 3. So we'll call delete method, we'll pass the position as 3 and the algorithm remains the same. At the first step we check whether position is equal to 1 or not. So position is equal to 3. So this condition comes out to be false. Now as we want to delete the node at position 3, we somehow need to traverse to position 2. So for that we create a temporary list node previous which starts from head. We create an integer variable count which starts from 1. So now in order to reach to a node which is previous to node which we want to delete, we simply provide a while loop. So now here you can see this count variable will help this previous to reach to a position which is just before the node which we want to delete. So we provide condition as count should be less than position minus 1 because we have initialized already count by 1 and previous is already pointing to head. So here you can see that value of count is 1. If we do position minus 1, we get 3 minus 1 which is 2. So 1 is less than 2. So this condition comes out to be true. And inside this while loop, we simply traverse previous to its next node by assigning previous.next value to previous. So previous is pointing to this node and its next is pointing to this node. So after this assignment, previous will point to second node via this link. We'll increment count by 1. Count becomes 2. And now here you can see this condition comes out to be false because 2 is not less than 2. So this while loop will terminate and we know that we have reached to a node which is just previous to node which we want to delete, which is at position 3. So at the first step what we are doing is we are simply creating a list node current which will hold the value of previous.next. So previous.next is this node which we want to delete. So current will point to this node. And now using previous and current, we'll simply break this link and we'll assign this link to current's next because we want to free this node. So we can only free this node if we break this link. So here what we do is we simply assign value of current next which is null to previous next. So this link will go away and previous next will point to current's next. So after this method gets over, here you can see current was a local variable. So this node won't be referred by any other node. So this will be simply garbage collected. And our singly linked list will become a list having two nodes 8 and 10. And the last node will be removed. So friends, in this video we saw that how we can delete a node from a given position in a singly linked list. I hope you have found this information useful. And in case if you find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.